Hello friends, welcome to the part 22 of the video series on flexible packaging. In this part, we'll discuss ink efficient rotogravure engraving. Reducing ink consumption through cylinder specification optimization is one of the most effective and underutilized strategies in rotogravure printing. Since the gravure cylinder determines how much ink is picked up and transferred to the substrate, its engraving parameters directly influence ink usage. First, let's understand the parameters that decide the engraving specifications of the rotogravure cylinder. 1. Design parameters. 2. Printing machine parameters. 3. Ink and substrate parameters. And 4th, cylinder and engraving process parameters. Design elements are explained here. Dark to light tonal range, solid areas, line work, text and fine text, and half tone. Now let's understand design parameters and their impact on engraving specs. Solid areas in design require lower LPI and deeper cells. Fine text needs higher LPI and shallow cells. Wider tonal range needs finer engraving and depth modulation. High ink coverage demands larger cell volumes. Line work or text requires precise high LPI with sharp stylus and shallow cells. White or metallic ink needs very low LPI and high cell depth for opacity. Now let's understand printing machine parameters and their impact on engraving specs. Higher machine speed requires finer engraving and optimized cell depth to avoid smearing and drying issues. Matching blade tip shape with engraved cell geometry ensures precise ink laydown, sharp print edges, consistent GSM, and reduced blade wear. Impression roller hardness affects ink transfer and cell release. Electrostatic assist allows use of shallower cells by aiding ink transfer. Here I suggest you to watch a video about a complete guide to rotogravure printing machines, part 1 to part 3. Scan the QR code to explore more about the video. Now let's discuss impact of ink and substrate parameters on engraving specs. Water-based inks may need higher volume cells due to higher surface tension. Thicker ink requires deeper or more open cells. Slow dryers need lower volume cells to avoid smudging. Non-absorbent substrate like PET need more controlled laydown with finer specs. Now let's discuss impact of cylinder and engraving process parameters on engraving specs. Copper thickness limits maximum cell depth. Laser allows shallower, sharper cells. Electromechanical allows deeper cells for solids. Stylus angle controls cell shape. Hexagonal, pyramid, square cells affect ink transfer efficiency. Chrome layer thickness affects wear life and blade interaction. Now let's summarize. LPI, that is screen count, is determined by design details, tonal range and resolution needed. Cell depth is determined by ink volume requirement, machine speed and blade specifications. Cell volume is determined by targeting GSM, opacity and substrate. Cell shape is determined by stylus angle and engraving method. In rotogravure printing, the engraving specifications of the printing cylinder determine how much ink is picked up and transferred onto the substrate. These parameters directly affect ink consumption, print quality, drying time and cost efficiency. Here is a detailed explanation of the main engraving specifications and how each one affects ink consumption. Line count or LPI is the number of engraved lines or cells per inch on the cylinder surface. Higher LPI means finer cells. There is less ink per cell, that means lower ink consumption. Lower LPI means coarser cells, that means more ink per cell. That's why higher ink consumption. Use high LPI, that is from 140 to 180 lines per inch for fine text, gradients and CMYK halftone. Use low LPI, that is 80 lines per inch to 120 lines per inch for solids, whites and metallic. Cell depth is the depth of the engraved cells on the cylinder surface. It's measured in microns. Deeper cells hold more ink, that is higher ink usage. Shallower cells hold less ink, that is lower ink usage. Let's see typical ranges. For fine halftones and text, generally the cell depth is 24 to 30 micron. For process colors CMYK, cell depth is 30 to 36 micron. For solid areas, cell depth is generally 36 to 48 micron. For white ink, cell depth is 45 to 60 micron. The 3D structure of the cell depends on the engraving method. There are 3 engraving methods: electromechanical, laser and chemical. In electromechanical engraving, cell shape is elongated V shape, that is helioscope. Its effect on ink is very smooth. In laser engraving type, cell shape is diamond or hexagonal cells, or it can be custom-made cells also. Here the effect is sharp details and high control. Means ink can be controlled. In chemical engraving, cell shape is rounded or inconsistent. Here the control over ink consumption is very less. Efficient cell shapes transfer ink more cleanly and reduce leftover ink and consumption. Poorly formed or inconsistent cells increase waste and overconsumption. Cell volume is the total volume of the ink held by the cells per square meter of cylinder surface. This is the most direct indicator of ink consumption. Higher cell volume means more ink transferred, means more ink consumption. Lower cell volume means thinner ink film, means lower consumption. Cell volume range and its application are mentioned in the table below. Screen angle for CMYK is not a direct ink consumption factor, but proper screen angles prevent moire patterns and allow tighter control over dot gain, which indirectly affects ink usage. Here is the summary table. You can go through the same. Here are some pro tips to optimize ink via cylinder specs. 1. Use high LPI plus optimal depth for CMYK jobs. 2. Limit depth for non-critical solid areas. 3. Use high opacity ink to reduce required cell depth. 4. Calibrate cylinder specs during fingerprinting. 5. Regularly audit ink mileage versus cylinder engraving data. Scan the QR code on the left to explore more about Rotogravure printing cylinders. If you have still not watched video on action plan to optimize ink consumption and costing, then I recommend you must watch that video too. Scan the QR code to explore more about the video. Let's start with a detailed explanation of how changing cylinder specifications can help reduce ink consumption with technical reasoning and practical examples. Deeper cells hold more ink, resulting in higher ink consumption. Reducing depth appropriately without compromising print density leads to less ink usage. Finer engraving, that is higher LPI, distributes ink more evenly and in thinner films. Coarser screens, that is lower LPI, deposit thicker ink layers, often more than needed. Different engraving technologies create different cell shapes, which affect ink release and hold. Here is the example 1 about solid color area on PET substrate. All cylinder specs was line count 120 LPI, cell depth 48 micron. Ink consumption was 3.2 kilo per square 1000 square meter. Optimized cylinder line count was increased to 150, cell depth was decreased to 36 micron. So ink consumption decreased by 28% without loss of print density due to better surface tension and transfer efficiency. Example 2 is about text and fine line graphics on matte BOPP. All cylinder was of 100 LPI and 40 micron depth. Problem was too much ink fill and lattice bleeding. New cylinder was of 160 LPI and 28 micron depth. The benefits were sharper text, less ink coverage, no dot gain, and ink reduction by 25%. Example 3 is about white background cylinder on reverse printed PET. White ink typically has high consumption. All specs were 80 LPI at 60 micron depth. Ink consumption was 6.5 kg per 1000 square meter. Optimized specs were 100 LPI at 48 micron depth. ink consumption reduced by 23%, and benefit was faster drying due to thinner ink layer. Here is the guidelines for cylinder specification optimization. For a different print type, suggested LPI range and suggested cell depth range is given. Some additional techniques to support ink reduction. 1. Use high opacity white ink allows reduction in cell depth. Surface treatment, corona or plasma treatment improves ink adhesion, so less ink is needed for same visual density. Ink formulation. Work with suppliers to match viscosity, surface tension to optimize cells. Print density monitoring. Use densitometers to adjust spec instead of just relying on visual quality. Key takeaways. By reducing cell depth of the cylinder, you can save 10 to 30% ink. Lower drying time is the added benefit. By increasing screen count, that is LPI, you can save 10 to 20% ink. Sharp image and text is the added benefit. By optimizing white ink cells, you can save 15 to 30% ink. Use advanced engraving technology and you can save 10 to 15% ink. Added benefit is uniform transfer and reuse. For high quality laser engraved cylinders optimized for ink consumption from Rotogravure, feel free to reach out to me at 96500 47650 and email address rajesh.modvadia@rotogravure.com. In the upcoming videos, we will explore prepress parameters that influence and help optimize ink consumption. When every micron of your cell is engineered, every gram of ink is saved. Thank you for watching this video till the end. Do subscribe to my channel.